Alright, what's up guys? So, while I was editing my last two videos, I was kind of realizing that I hadn't actually explained very much about OCaml itself. I was kind of so caught up in trying to use OCaml myself that I wasn't really explaining what was going on. So, yeah, and I also realized that a lot of the viewers maybe are not that familiar with OCaml. So, I wanted to take this video to kind of recap my solutions to Advent of Code Day 1 and 2 and actually kind of explain my thought process and what these things I'm doing actually are. So if we take a quick look at the input file, just to remind us what we were actually trying to do, the challenge for Advent of Code 2022 Day 1 was basically to parse each of these groups of lines. Each of these represents one elf, and the numbers are individual food items, I guess, that the elves are carrying. And so we were supposed to come up with the total calories per elf. Each line is one pack of calories. So basically you had to combine each little cluster into one number. And then we're supposed to find the top elf for day 1, so the elf with the most calories. And in part 2, we had to find the top 3 elves. We'll start at the top of the file, which is often a good place to start. The first function we defined was called load file. And you can see that this is actually pretty simple. We use this module from, I think it's from base. Let's see if it tells us. Okay, it doesn't seem to tell us, but we use this module called inChannel. We create, so this is basically an input channel. So I think of this basically as standard in. But I guess in general, it's just any input, so it works for files as well. So we call inChannel create file name, and then we've got this funny pipe looking thing that I use all over the place. And it really is a lot like a shell pipe. So this basically takes the output from this command and pipes it. It takes the output from this command, which in this case is an inChannel, and provides it as the first argument, or I guess last argument, to this next function. So this function, if we look at the documentation, doesn't give us much help. But what it does is it reads from this inChannel, reads all of it into a string. So this, if you're familiar with Rust, this is very similar to standard fs read to string. This load file function is pretty much all we're doing. And I did find in the documentation later, I think there is a single function we could call, read all file name. I think would also give us the right answer. But I didn't know that at the time. So there's load file. We explained the original implementation and actually fixed it up a little bit. So you see this definition is basically the same length as this, so maybe we don't even need load file necessarily now. But there you go. There's load file. Now, the next thing we've got here is this thing called get elves. So this is where things get complicated right away. And I actually had a really hard time doing this initially because if we go back to our input file, what I really wanted to do was split the whole file on double new lines. So this is what I did in my Rust implementation, because if you split them, you split on the double new line, that immediately gives you the cluster. And then if you split the cluster on new lines again, then you get each individual element and you can act on those directly. Now, the issue I ran into, sorry, we have to skip around a little bit. We'll come back to get elves. But you'll see that in my main function, which in OCaml is denoted with this, with just let unit equal. First we define a function within the main function, so we'll skip over this line for now. But I call load file, which we talked about. I pipe that into string.split. What you're seeing here is a keyword argument. So I'm telling it what character to split on. And what I just said is actually the problem I ran into last time with my implementation, is that string.split splits on a character. It doesn't split on multiple characters or on a string. It only splits on one character. So this was basically making me use, and actually I found later again that I can actually use split lines for this, and that should still work. So that's what caused me all this trouble. So I had to come up with some other way of actually handling these empty lines, rather than splitting them out immediately. So that's what brought us into get elves. So you'll see that what's coming out of string split lines is a list of strings. So that's why I called this list. And you'll see down at the bottom it's actually saying that it's a string list. OCaml, in my opinion, kind of writes the types backwards, but it feels kind of natural once you get used to it. So if we had like a list of option strings, you would say like string option list, I think. Whereas in Rust, you would have something like vec option string. OCaml would say string option list. I'm pretty sure. So it feels a little bit backwards, but the fact that it's completely backwards actually helps me remember. Okay, so we're in get elves. We're handed a list. So what do we do with that list? Well, what I decided to do was actually call this thing called list fold. Now, folding actually took me kind of a little while to get used to when I started learning these functional languages. And Rust actually has a fold method on iterators as well. So if you master the fold, you can use them in Rust. But the basic idea of a fold is that it's fairly similar to a map, except, and I guess I should say what a map is. So when you say something like in OCaml, you can say list.map. And again, you can't really see my horrible color schemes, but it takes a list and a function and returns another list. So what it does is it applies this function you give it, f, to every element of the list and returns a list of the results. What fold does, and we can kind of see this from the type signature, is it takes a list of some generic type tick A. I think in OCaml they call it maybe alpha, but because I'm used to Rust, I'm going to call it tick A. So we take a tick A list, we take this thing called init, which is tick ack, and this is something you'll see a lot with folds. So usually the function that you pass to fold takes an accumulator. And so the function takes both an accumulator and an element from the list and returns a new accumulator. So probably a simple use of fold would be to write like a sum function. So let's say you're summing integers. You could write something like this. List.fold. It takes a list of ints. Init is 0. And f will be fun, ack x, ack plus x. And I forgot the colon. There we go. So that would be how to write a sum of a list of integers. So now we can take a look at what I'm folding over. So you see that I'm actually going to be producing another list because my accumulator is initially an empty list. And then we've got this function, which you can see actually occupies the rest of our outer function. Again, it takes the accumulator and elt. So I picked up this stuff from probably Paul Graham's on Lisp or some other Lisp book I read, but you use this for list and elt for an element of the list. So we take the accumulator and an element, and the first thing we do is we do string equals. So this is a kind of funny way of accessing operators, I guess, inside of a module. So if we just wrote equals here, we would get an error because I think base, yeah, this expression has type bool, but an expression was expected of type a list. And of course we would actually have to do it like this. Yeah, this expression is type string, but an expression was expected of type int. So OCaml, this is getting kind of into the weeds, but OCaml comes with like a polymorphic equals operator. But as explained in real world OCaml, this can get you into some trouble. So base actually overwrites that polymorphic equal and makes the default equals only apply to ints. So if we want to access the equals for a string, we can actually take the string module dot, and we access the operator almost like any other function, but I guess because it's an operator, we have to wrap it in parens. So this is just how we get string equal. And we're just calling it like a normal function, not like an infix operator. So we're saying string equals else this. Now, let's go back to our input. If we find an empty line, then we just push 0 onto our accumulator, because we're going to modify that later on. Otherwise, so in this else case, we're on one of these numeric lines, then we're going to let I equals int of string elt. So we're just going to be converting each of our lines, because again, we're passing in a list of string. Convert each of our strings to an int, and then we match it, and we match our accumulator. So if our accumulator is empty, then we just return that element in the accumulator. Otherwise, if there's something in our accumulator already, this is how you destructure a list. So again, because I'm more familiar with Lisp, I usually read this operator as cons. So I would say head cons tail. So we're basically pulling, head is like basically the car of the list. So we're going to pull off the head of the list and the tail of the list separate, and then we return head plus I. So basically we're just adding I to the first element of the list. And then we put that back in a list with the tail. So we pull out the head temporarily, add I to it, put it back. And that's our map function. So that has the effect of adding up each of these chunks and returning us a list of integers. So that brings us back to this section of the code. After we do that, we get one entry in our list for each of these clusters, and the way I pull out the value I want, so again, in the first case we want the maximum value, and in the second case we want the top 3, what I do is just sort that list, and when we sort it, we have to pass it a comparator, which again we can get from the module of the type we're interested in. So I say compare using int.descending. So I want a descending sort. And then I call take 3. Now, what I really wanted to do here was just write list.take3, again with my pipe operators. But the unfortunate aspect of list.take is that it takes the list as the first argument and then the number to take. But to use the pipe, what we actually needed was the opposite argument order. So I just defined this little function to swap the order of arguments so that I could use the pipe. So I say take 3, and then again I use list.sum. We'll come back to this in a second. Well, no, I guess this is where we are. We'll talk about it now. List.sum takes a module. This is like a module literal. And I forget actually exactly why it needs that. I think it is to provide probably an addition operation. So let's see what it says. Yeah, it has to take a module that is summable with type T is sum. So this is kind of like traits in Rust, I think. At least that's how I think of it. I mean, this part especially sounds like traits. But I'll say a little bit more about this in a second. And then when it's summing them, it also applies a function to it. So I just use the identity function from the fn module. And then finally, once we've summed these take 3 up, we can pipe that to printf and get our answer that we see. Yes, that we see here. Okay, so not too bad. Now, yes, the one thing I wanted to say about OCaml that I find interesting is that you'll notice we didn't actually have to write types anywhere. So this is one of the, this is one of the big things about OCaml is that it has really strong type inference. Like, I didn't have to say that load file, I didn't have to say file name is a string and this returns a string, or this returns a string list, I guess. Is that right? Oh, it returns a string. My bad. I didn't have to write that because it can be inferred. However, the flip side of that is that you actually end up writing types in a lot of places you might not expect. Well, maybe not that you wouldn't expect, but I guess in places I wouldn't expect coming from Rust. For example, I find it strange that I have to write list.fold if I knew that this were a list. So I feel like in OCaml, you actually end up writing types just as much as in Rust, but you have to write them in different places so that the compiler can figure out where you would have written them in Rust. So for example, in Rust, I would say that this is a list, and then I could just call .fold on it, and the compiler would know. So I would declare the type up here, and it wouldn't have to infer it here. Same thing here. I'm pretty sure this string equals is helping the compiler to infer that the type of elt is string, whereas in Rust, it would know somewhere else that the type was string. So I could just call elt.equals. Same thing here. In Rust, I would just call elt.parse. And probably I would actually have to annotate that in Rust. Parse often gets you into turbofish territory. But yeah, a lot of these other places you wouldn't have to write stuff like this. So, and that's not really a criticism. It's just a different approach, right? Because the compiler has to know the type somehow. So you write types one place or the other. It's just that the inference isn't magical is really the point I wanted to make. So there we go. Let me know in the comments if you guys enjoyed this kind of breakdown video. It felt a little more enjoyable for me, I think, rather than just recording my struggles of actually typing it out initially. But yeah, let me know what you think. Do you like the implementation videos, watching me struggle, or would you rather have these short summary videos? Because I think that's what I'll probably stick to in the future. As always, thanks for watching, and I'll see you guys next time.